Hey, what's up, guys? Today we're going to go over rotation about a point. So this is different from yesterday or the other video because instead of rotating about the origin, we are now going to rotate based on a different point. So a rotation on a coordinate plane where the center is about a point other than the origin can be accomplished by observing here will be horizontal and vertical distance of each vertex formed from the center of rotation. In other words, we will be looking at the slope, which like the last video, you might remember us talking about the slope a little bit when coming up with the rule for 90-degree rotations. So here's essentially how it's going to go. You can listen to me. You don't have to read these steps 1 through 5 on the side. So here's the situation. Say we have the point P right here at 3, 4. Okay, that is right here. Call this P. And it wants us to rotate this point around the point 1, 2. So 1, 1, 2. This is the point we are to rotate around. So let's take a pause right here. Point P is the point we want to rotate, and the point we're rotating around is the black one at 1, 2. So here's what we're going to do. Let's draw a vertical and horizontal line through this new center of rotation. Okay, that might help us out here. Now, from these new, you can imagine these as the new X and Y axis, and you could sort of imagine that center of rotation as our new origin. Again, this is pretend. Okay, and all we're going to look at is the change in Y and change in X from the point, our center of rotation, to the point we want to rotate. So let's do that. 1, 2. So our change in X here is 2. Our change in Y here again is 2. So our change in X and change in Y is 2, 2. So those rules we learned for when you're rotating about the origin, we can still use them. The thing is you cannot use it on the original coordinate or ordered pair. You have to look at the change in X, change in Y, and then use the rule for that point. So don't forget, for 90-degree rotation counterclockwise, we go from X, Y to negative Y, X. Okay? So 2, 2 now becomes negative 2, 2. And now this is the direction we are going to move in the X and Y direction from our center of rotation. So we have our change of X and our change of Y here. We did use our rotation rules. We just used it on the change of Y and change of X, not the original coordinates of point P. All right. So negative 2, 2. So all that means is from the center of rotation, we are going to go 2 to the left and 2 up. And that turns out to be right here. And this is at negative 1, 4. So we successfully rotated this point, P, around a center of rotation of 1, 2. And you look there, a little 90-degree angle here. And so that pretty much encapsulates the way it works. So we can use those rules again for 180 and 270. So let me erase this. Because again, our change of X and change of Y is still 2, 2. That part's not going to change. So let's not forget our 180-degree rotation rule is that you go from XY, and let me rewrite it here. You go from X, Y to negative X, negative Y. Okay, so again, do that to 2, 2. Now we have negative 2, negative 2. Okay, so again, This is indicating our change in x and change in y from our center of rotation. So this means we're going to go 2 to the left because it's negative, and 2 down, again, because it's negative. And that ends up being right here. So that point is -1, 0. Okay, and that indeed looks like a 180-degree angle. Lastly, I will leave 270 degrees up to you. That is pretty much it. Thank you.